Right, hi Year 11s, this is Mr. Lim here again, and this is our third video in the acid-base series about strong and weak acids, so let's get started. Alright, we're going to be learning about this stuff. Okay, and so, strong and weak acids. So, under Arrhenius theory, alright, so if we're still under Arrhenius theory, acid molecules break up into hydrogen ions and anions, okay, so anions have a negative ions, right? So, for example, HCl will break up into H plus ions and Cl minus ions. Okay, so hydrogen ions and anions. Okay, so let's have a look. Different acids break up differently depending on their nature. Okay, so what does that mean? Some acids will have all, and this is the key idea, all of their acid molecules break up into hydrogen and hydrogen ions and anions. Okay, these are called strong acids. Okay, the key here is the all. Okay, but some acids will only have some, and this is the key idea, some of their acid molecules break up into hydrogen ions and anions in solution. The remaining acid molecules will stay in molecular form. These are called weak acids. Okay, so for example, this is a strong acid, right? Oops. All right. So this is a strong acid, HCl. Okay. So if I have 100 of these, they turn into 100 of these and 100 of these. How are you getting 200 things out of 100 things? Because remember, you're splitting them apart. Okay. But if you had a weak acid, and an example of this is ethanoic acid, right? That will split into H plus and CH3COO minus. Okay. However, you might end up not with 100 of the H plus and the CH3COO minus. You might end up with only 3 of those hydrogens and 3 of the CH3COO minuses, because only 3 of the 100 CH3COOHs broke up into the 2 component parts. That means that there are 97 of these acid molecules. So acid molecules stay in molecular form. Okay, so for remaining acid molecules, that's the 97 here, will stay in molecular form. And so therefore this, if it occurs like this, it's called a weak acid. Right? If all of the acid molecules split up, it's called a strong acid. Okay, so the difference is all versus some of the acid molecules break up. Okay, okay, let's have a look next. So key ideas is the amount of moles of acid molecules introduced into the solution per volume is the concentration of the acid. So this is not the amount of hydrogen ions that are produced. This is the amount that was introduced into the system. So that's this amount, 100 here, 100 here. If you put 100 of these in and 100 of these in, you'll end up with different amounts of H plus and different characteristics of those 2 solutions, right? So if equal concentration, so we're saying 100 per 100 of those things, of the acid molecules of strong or weak acid are compared to each other, they will have different properties due to the different amounts of hydrogen ions found in solution. So the idea is that you started both with 100, but now this one here only has 100 H plus ions, this one only has 3. They're going to have different properties. Okay? So, let's have a look. Strong acids will have more ions in solution, therefore more conductive of electricity. Strong acids will have more hydrogen ions in solution, therefore their pH, and this is something that we'll cover later, right, will be lower. And strong acids will have more hydrogen ions and will react faster. Okay, and if you remember from year 10 rates of reaction, the idea is that there are more of those hydrogen ions, and therefore they're going to be more frequent collisions, and therefore their rate of reaction is going to be faster. Okay, so other key ideas. If the concentrations of these acids are different, then the concentration of the solutions has to be taken into account when describing the properties. Okay, so in this part here, we were dealing with equal concentrations of strong and weak acids. So that's what we're saying. Okay, we have equal amounts, 100 here, 100 here, right? But if we were to have 100 of the HCl's, but 1 or 10,000 of the CH3COOH, right? Then, because this one is much more concentrated than that one, you're going to have a very different outcome, okay? So this one here might be 300 of these split apart, right? But and 9,700 stay together, right? But now, because this one is much more concentrated than this one, it's going to have more conductivity, right? And it might react faster because it's got more of these H plus ions in solution, right? So a strong acid, which is what we had at the top, a HCl, a strong acid with low concentration can have a lower conductivity than a weak acid with higher concentration. That's what we were just talking about. All right, so let's move on. Strong and weak acids. When strong and weak acids react with other chemicals, the hydrogen ion takes place. All right, takes place in the reaction. So it's really those hydrogen ions that do the work when talking about reactions of acids. Okay, so even though in solutions, weak acids have less hydrogen ions at any point in time. Okay, they have the ability to create more hydrogen ions from the unsplit acid molecules. Okay, so what this is saying is that, okay, here's my CH3COOH, my weak acid. All right, I started off with 100 of these, and they're going to split into their H plus and CH3COOH minus. Okay, and I'm going to end up with 97 of these and 3 of those and 3 of those. So when the strong and weak acids react with other chemicals, it's this substance here that does the reacting. So when this reacts with it, right, its number might go down to 0 because it's been used up. However, more of these can turn into these over time. So in the next period of time, maybe this thing goes to, well, that's 97 and that's 3. So those get consumed. So this now goes to 93 and those 3 replenished, and now you have 6 of those because another 3 have split apart. Okay, so the main idea here is that if equal, oops, no, that's not what I wanted. If equal numbers of moles of strong and weak acids are reacted with other chemicals, they will react to the same degree. So what a lot of people think is that, okay, because you've got less of these H plus ions at any given point in time, that means that only 3 of these are going to react. So that's not true. The idea is that all of these will react. So if you have 4 moles of this, all 4 moles are going to turn into this at some point when you react it with something. It's not going to all turn when it's just sitting in solution, just doing nothing. But when you react 4 moles of this, you are going to end up with 4 moles of this to react with whatever you're reacting it with. All right, so that's something that's quite a common mistake. So you just need to remember that however many moles of this is going to react with whatever you're reacting it with. All right, so let's move on. This is a list of strong and weak acids, and if you do not know the formulas for these, you really should, because it's something I've probably asked you to memorize. Okay, but here they all are. Oops, that's not what I wanted. Here they all are, just in case you haven't seen them yet. Okay, and that's classifying them as strong and weak acids. This is something you're going to have to memorize. Just deal with it. Okay, so when you get to write out these acids in equations and reactions and stuff, okay, so we're generally going to be writing them out in ionic equations. And strong acids are just shown as the hydrogen ions, because remember, in ionic equations you try and remove spectator ions, and because they fully split apart, the hydrogen ions are the things that do the work. So the other ion, the anion, sits around in there and generally does nothing, right? But the hydrogen ion does all the work. So that's the one that you show in your ionic equations. If, however, the salt produced is precipitated, so that means the anion does something, the anion of the acid is also shown in the reaction on both the reactants and the product side, but separate from the hydrogen ion. Okay, so if you're reacting say, let's do HCl, right? You should recognize that that turns into H plus and Cl minus, okay? If this turns into a precipitate, say you react it with something with silver ions, then you would show it like this, maybe with AgCO3, and we will deal with this one later on, all right? But you would show it like this, AgCl, and you would have that as a solid because that's a solid, right? And we'll deal with that in another video, but the idea is that that's how you would show it in the equation, okay? However, weak acids are shown in as their acid molecules, okay? So because they don't split apart and majority of them stay in their acid molecule form, they are shown as their acid molecule form, right? If the anion produced from the acid is always shown as a product on its own, okay? So the acid molecule is there, and then the anion is shown as a product because it's split apart from the hydrogen in the acid molecule, unless it partakes in the precipitation reactions, in which case it's shown not on its own, but as the precipitate. Okay. Another way to show that something is a weak acid is that double arrows are used to show that the acid is weak. And so what is a double arrow? A double arrow is something that looks like this between the reactants and the products instead of a single arrow. Okay. So something like CH3COOH, which is a weak acid. And if I was to react it with a base, and we'll go with these ones later on, okay? So you would keep this together, and then you would show CH3COO minus as the anion produced, right? And that would form water and, Na plus if this is a solid. But we'll go through those ones more later on, okay? So the idea is that the anion produced, that's this one, is shown as a product on its own, right? And the weak acid is shown as its acid molecule, is that one there. Okay, and that's it. Adios.